Good afternoon, everybody, and welcome to this webinar titled Short Introduction to EM or Electromagnetic Simulation inside SolidWorks. My name is Arvind Krishnan, and I will be your host today. On behalf of EMWorks, I would like to thank you all for attending today's webinar. Just before I start this webinar, just a few bookkeeping items that I would like to remind you. Please note that this particular webinar is going to be recorded, so you will have a chance to view the contents later, as a link to this recording will be sent to you by email. Next, if you have any questions for me, I would request you to type in your questions in the chat section, and towards the end of the webinar, I will try and go over some of the questions for the benefit of the audience. Let us start with the agenda for today. I'm going to start with why FEA-based electromagnetic simulation. What are its advantages and why one should consider using this technique. Next, I'm going to go over how EMS for SolidWorks really fits into the entire simulation space offered by other SolidWorks products. Then we will look into some applications and key industries. I will also do a brief product demonstration so that you can get an idea of how EMS for SolidWorks fits into the SolidWorks ecosystem, and you will be seamlessly able to convert your SolidWorks designs into electromagnetic simulations. Finally, we will recap and I will go over some product information with you. Now let me start with why FEA-based EM simulation. When engineers design their electromagnetic products, most likely they have a concept that they probably are utilizing a CAD system to envision. By using a CAD software like SolidWorks, they're able to rotate, to view their models, see if there are any interferences, see if their thoughts and ideas have come into place correctly. Also, the CAD system has numerous other benefits where you could create the drawings and so on. But there is always a question when it comes to EM designs is, will my design perform to my expectation? So most likely the engineers have done some hand calculations and so on, and there's a small probability that there's still a doubt lingering in them that will this perform to my expectation? Now, FEA-based EM simulation will answer these questions even before you do a prototype of your concept. This is a very proven technique, and it is known to give accurate results, which matches well with experimental as well as theoretical values. Oftentimes, when engineers are designing their electromagnetic devices, it is very difficult to visualize certain concepts, even in a lab. For example, magnetic flux, although exists around an electromagnet or a permanent magnet, it's almost impossible to see it. You can only feel it by using some techniques, for example, by introducing a steel member where you can get the forces and so on. So it is not something that is conceivable to the naked eye directly. So for viewing these kind of quantities, an FEA-based electromagnetic simulation will become really helpful. Also, with regards to safety, for example, you're testing some high voltage devices. There's always safety involved in your test. You know, there's also a limitation to the amount of voltage that you can actually reproduce in a laboratory environment and so on. So FEA will allow you to test the worst case scenarios and go much beyond what is conceivable in a usual laboratory setting. And finally, the ability to not prototype till you're 100% sure that the design will work perfectly gives you a peace of mind that your designs will be always functioning as per its requirement. Now let's really understand where the electromagnetic simulation falls into place in the ecosystem of SolidWorks simulation. Now, as you may all know that the SolidWorks simulation, which is a part of the SolidWorks suite of products, consists of several different simulations. Today, you can do a structural simulation, you can do flow, you can do plastic simulation, but EMS for SolidWorks is a gold certified SolidWorks simulation product that can actually bring this missing piece into a CAD embedded simulation environment inside SolidWorks. Now this gives you a broad picture of the product-wise applications that we cater to using the EMWorks products. Right from DC voltage all the way to several gigahertz, we can actually deal with the electromagnetic spectrum. We have two products, EMS for SolidWorks, which is really going to be the topic of discussion today, and high frequency HFWorks. Now, EMS for SolidWorks really falls under the electromagnetic and electromechanical design space, where one can use these products to conceive and design motors, linear generators, relays, solenoids, loudspeakers, coils, transformers, etc. On the other end, when you're looking at high frequency passive components, RF and microwave components, which is really in the electronic designs, antennas, etc., signal integrity, we have a product called HFWorks. And this year we will be doing a series of webinars focused on HFWorks. And as a result, we will not be focusing on this product in today's webinar. And also they range from a wide variety of industries, right from automotive, transportation, aerospace, energy, life sciences, consumer goods, and so on. Now, before I go into further applications and showing you a demonstration of EMS product, let me just go over some of the product bundling that we sell today. Now, EMS product comes under various flavors. One can get what is called as EMS Electric, which has both 3D as well as 2D capabilities. We have three different solvers under the EMS Electric package: electrostatic, AC electric, and electric conduction. And you can also add on a thermal simulation to this. EMS Magnetic again has both 3D as well as two-dimensional capabilities, consists of magnetostatic, AC magnetic, and transient magnetic solvers. And you have a plethora of coupling options available in the form of thermal, motion, structural, and circuits as an add-on. EMS Professional and EMS Premium are all convenient way of packaging the above mentioned products. EMS Professional consists both of the electric as well as the magnetic solvers without any coupling or add-ons. And the EMS Premium is really all of the above. So if you have multiple applications that range from electric to magnetic and you're interested in coupling to thermal, motion, etc., EMS Premium should be your natural choice because it gives you a price break when you bundle multiple products together. We will be looking at this product bundle towards the end of this presentation as well. So let me go ahead and proceed. And I just want to let you know that we are very proud of our customers and we are really happy that they are finding benefit in using our product. So some of our notable clients are mentioned here, and worldwide over 600 customers use our product successfully today. Now let us look at some of the application spaces with regards to EMS for SolidWorks, which is really a low frequency electromechanical field simulation solver. One of the first application areas is the solenoids and actuators. In this particular application, the EMS product really helps in understanding how your coil, in the case of electromagnets, perform. What is the excitation of the coil? What kind of flux it produces? Does it actually produce enough force to move your actuator, and so on? And one can actually couple with a motion simulation to really understand the dynamic response of the movable plunger or the moving component in an actuator or a solenoid study. Next, the world of permanent magnets. EMS can actually be used to study arrangement of permanent magnets, to visualize the magnetic field, to visualize the forces acting on components that are close to these permanent magnets. And this is particularly useful because a lot of revolutionary and very exciting accessories for the electronic industry arise out of using the permanent magnets. We have superior locking system for your phones. We have latches that work with permanent magnets. We have magnet arrays that actually help you to produce magnetic field in one direction versus the other, and so on. So EMS can actually be used to test and validate interesting ideas involving magnets. Another traditional field where EMS can be used is in designing loudspeakers, where EMS can actually help to determine the force acting on the coil and thus get a visualization of how the loudspeaker coil vibrates. Electrical machines is a big application for area for EMS. So here, electric motors, EMS can actually help you to compute the performance of your motors, like the torque speed curve, the efficiency map, etc. So one can use EMS really to reduce the stators and the rotor, the steel used in motors. This has various applications. Electric motors is a big industry by itself, from electric vehicles to electric power tools. So EMS plays a major role in helping you conceive and design your electrical machines. And also by coupling with the thermal simulation, one can actually understand how hot their motors get and so on, and what are the losses experienced in the motor. EMS actually plays a big role in the power industry, high voltage power industry. And here engineers can use EMS to design insulators, transformers, sensors, etc. One of the major challenges is really to predict breakdown for high voltage components, and EMS will be able to do that. It can predict the corona discharge and breakdown that occurs due to high voltage applications, especially in electricity distribution and transmission. And also, some of these high voltage components are really expensive and difficult to test in a laboratory environment, thereby making EMS a very ideal choice to simulate their performance. Again, in the field of power electronics, if you want to design capacitors, inductors, etc., and want to study the performance of these devices, EMS is a very ideal environment where you can design your power electronics in SolidWorks CAD and you can study the effectiveness of these things. For example, the core loss that occurs in your inductors and so on. So without further ado, let me go ahead and introduce to you EMS for SolidWorks. And here I'm just going to use this product demonstration to give you the workflow involved in doing a simulation using EMS. Now, if you see my screen, what I have here is a rotational actuator. Now, this is a model that is created using SolidWorks, as you see here, SolidWorks CAD. And the objective of this particular simulation is to use EMS to understand what is the torque acting on this rotational actuator when I excite these coils. Now, to do a simulation in EMS, it is actually neatly located right inside SolidWorks. So when you install EMS, which is a gold certified product for SolidWorks, it creates an add-in and it creates the EMS feature manager right inside SolidWorks. Now here is where you would organize your simulations into various studies. Now for example, I've already done a study and I will refer to this during this presentation. But let me walk you through the steps involved in creating a simulation in EMS. The first step is really to create what is called as a study. So you can right click and create a study. Now there are several different study options that are available in EMS. For a rotational actuator that we see here, which uses DC current, we would resort to what is called as a magnetostatic simulation. There are also other study types that we will cover in subsequent webinars. Now, EMS has some very interesting features that allows you to parameterize your geometry or your current or other magnetic properties or inputs to your design. So parameterization helps you to do that. EMS also allows you to couple your simulation to various other multiphysics simulations like thermal, structural, or motion. But for this particular example, let us keep it simple and let us do a magnetostatic simulation where we can understand the torque acting on the rotational actuator when you energize the coils. So once you define a study, you're going to create a study tree as you see here. Now in this particular study tree, we have to do several steps, and these steps are really easy because you can march through these steps from top to bottom. The first step is to define materials for your various components that you see here. Now for example, the coils, they are made up of copper, and as you see here, to define a material you just have to right click and say apply material. EMS has its own material library that consists of several categories of commonly used materials. Now you can open the conductor material folder and you can select copper and apply copper to the coils. Similarly, the core and the outer core, they are made of a ferromagnetic material called steel. So EMS has a selection of various steels that are available. For example, steel 1010, and here the magnetic properties in the form of pH curve is also available readily with our EMS library. Now this material library is completely customizable, so if you have your own materials, you can actually populate them and use them for simulation. Now once you have the materials done, you have to now worry about the excitation. Now let us start with the coil excitation. Now to specify the excitation of the coil, one must select the components that comprise the coil. Then you have to select a cross-sectional face through which the conductors or the current is actually flowing. As you can see from the arrows here, the direction of the current. So you select the face that through which the current flows, perpendicular to the face. Now you have an opportunity now to specify the wire gauge of the copper coil. So you can specify the wire gauge. For example, this is a 19 gauge coil. And then you can specify the number of turns or the number of conductors passing through this particular cross section. And also finally specify the current value. So this helps you to create realistic wound coils where copper of a particular wire gauge is wound to form an excited coil. Similarly, we specify another coil here. And as you see here, we can specify the direction of current in this particular coil. And also, just like before, it has the same number of turns and the same wire gauge and carries the same current. So these are identical coils that you see here. They are energized using the same current. And we will now understand what is the force or the torque acting on the rotational actuator. To do that, we use a method called virtual work, which is a very commonly used method to compute forces and torques in finite element electromagnetic simulation. So we request the program to compute the torque acting on the inner rotating core. So once these definitions are done, we are now ready to run the simulation. Now EMS is a finite element type of simulation which makes use of what is called as a finite element mesh. So let me go ahead and show you the finite element mesh that EMS automatically created for this particular model. Now as you see here that the EMS has very powerful meshing techniques. It creates an automatically optimal mesh to ensure accurate results. It also has mesh control features, and it is intelligent enough to put high number of mesh elements on critical components, as you see here. Let me go ahead and hide the mesh so that we can go back to the model. Now once the simulation is complete, like I have run this simulation prior to this webinar, so we can jump right into the results. But before I go there, I just want to let you know a few things about our EMS solvers. The EMS solvers makes use of multi-cores in your machine. So if you have multiple cores, your solver is going to run much quickly. It also makes use of the RAM. So higher the RAM, the faster is going to be your solution. And EMS can easily deal with several million elements in a very standard computer of 12 GB RAM, i7 Intel based computers, both laptops as well as workstations. And one can do these types of problems in a matter of minutes. For example, to solve this particular problem, it took probably 3 to 5 minutes. All right, now that we have come to the results section, let us see the results. Now, for example, if you recollect, the objective of this particular simulation is to compute the torque acting on my rotational geometry. So I can actually read the torque value right from my table here. So the major torque is going to be torque about z-axis. As you can see, torque about x and y-axis are really small, several orders of magnitude smaller than the torque about z-axis. And we notice that the torque about z-axis is close to about 12.6 millinewton meter. So that's really the torque acting on this micro actuator, tending it to move in the negative z direction. So if you actually see, it's going to move. If you look into the screen, it's going to move, rotate towards your right hand side. Okay. Next, we can study the magnetic flux distribution in the model. So here you can see a plot of the magnetic flux distribution in the model. So you can see the maximum value is about 0.47 Teslas. So you can very well visualize from this that the steel is nowhere close to saturation for this particular value of excitation. I can do not just a 3D plot, but also what we call as a section plot. So here is a section plot of my magnetic flux density that actually helps you to understand the areas where there is high flux regions. For example, these red areas. One can also study the magnetic flux density as vectors. So here is a section plot of a magnetic flux density now as vectors, and you can see the flux as vectors going through and completing your magnetic circuit. Okay. So section plots and 3D plots helps you to visualize your magnetic flux inside your magnetic circuit. So the next question really comes to my mind is what happens if there is really some kind of a change in your input. Now EMS has a very easy way of bookkeeping its simulation. For example, I can drag and drop this simulation and then really create a clone of my previous simulation. And I can call it, say, study 2. Now here I can do changes. For example, what happens if I actually pump in more current? So what happens if I put in maybe 2.2 amps in the coils? So I changed the first coil, and then I will change the second coil as well to put a higher current, 2.2 amps. And then what we need to do here is, when we are ready, all we need to do is run study 2. So we're going to run study 2, and once the solution is complete, we will take a look at the results of study 2 and compare it with the results of study 1. Now this way EMS helps you to study multiple configurations or multiple designs, and then helps you to compare and contrast between the designs. So as you see here, it is solving the problem. And the total number of mesh elements here mentioned is close to about 245,000 mesh elements. Now, 245,000 mesh elements to solve this problem takes about a couple of minutes on a 12 GB RAM machine. So makes EMS solvers really fast. It has a multiple core, so it has dual core and makes use of both the cores while solving. Now the messages here in the solver kind of tells you what's really happening. Right now it's computing the force and torque values, and then it is saving the, it's now computing the field and so on. And finally it is writing the solution, and then once it's done, we are ready to take a look at the results. Now let's just go ahead, because we cloned the study, everything that we did earlier is available to us. Now we just have to see, now you can see the flux lines. It's completely different. We have jumped from 0.4 Tesla all the way to 0.9 Teslas, which is kind of understandable because we have increased the excitation current. As a result, you can see the flux lines here. Okay. Now I can also decide to show components. For example, I've hidden the air geometry, and I can go ahead and show them as well. And then I can see the new magnetic flux density as vectors. So you can now see how the flux vectors move through the air as well and goes into the rotational actuator, and you can study them. And you can also take a section plot as before, and we can understand how the new magnetic flux density is distributed. And last but not the least, I can go ahead and look at the torque acting on my rotational actuator about the z-axis. And just to compare the value of torque, I can go ahead and compare any two different simulations, and then I can see how the torque varied between the first simulation and the second simulation. So notice that obviously the torque has increased a lot because we have increased the current, and you can see the difference in the torque. So the torque has almost increased by multiplied by a factor of 6. Okay. All right. So thus, in this particular demonstration, you saw how easy it is to create a geometry inside SolidWorks and then do electromagnetic simulation inside EMS for SolidWorks. Now we only looked at one type of simulation, which is the magnetostatic simulation, which is what you would use when you have permanent magnets or electromagnets with DC current. Now we have other simulation types that we will cover in subsequent webinars. Okay. Now with this, let me go back to my presentation and continue by just recapping on the EMS product bundles again. Now, what we looked today in this product demonstration was just the EMS magnetic and EMS magnetostatic simulation. So we have several different product bundles. We have the EMS electric, we have the EMS magnetic, and what we saw today is also the 3D simulation where you create your 3D geometry in SolidWorks and do the simulation. Now, EMS can also do 2D axisymmetric and 2D planar type of simulations on both electric as well as magnetic types, which we will cover in a later webinar during the course of this year. Okay. So EMS electric, EMS magnetic, then there is EMS professional, which contains both EMS electric and magnetic, and finally EMS premium, which contains both electric, magnetic, and all the add-ins that are available in the form of thermal, motion, structural, and circuits. During the course of this year, we will try and cover all features of EMS using it via several webinars. So please stay tuned for our webinar series. And I also take this opportunity to introduce to you other products from EMWorks. Now we have a new product which is going to be released very soon. It's called MotorWizard for SolidWorks. Now this is a standalone product that helps you to design and create standard BLDC and switch reluctance motors in SolidWorks. So this is a product that is designed exclusively for electrical machines, electrical motors. It is a template driven product that helps you to design both BLDC as well as SRM, switch reluctance motors. It has both FEA as well as a quick calculator that helps you to understand the performance of your motors. We also talked briefly about HFWorks, which is in the high frequency space. It's mainly used to design antennas and passive RF and microwave components like waveguides, transitions, etc. And it can aid in the calculation of S parameters, signal integrity, and mainly used in RF and microwave domain. Now we will cover HFWorks separately in a webinar series. So if you're interested in high frequency products, please visit our website to understand the HFWorks webinars. These are the several different combinations of motor types that are possible using MotorWizard. So we just want to bring it to you that if you have BLDC motors where the magnets are inside, and then we have BLDC motors where the magnets are what we call as an outrunner model and in-runner models, we can do those. We can also do both outrunner and in-runner switch reluctance machine. And what kind of results one can expect from MotorWizard? So all kinds of machine results that are critical for motor designers are available. We have in the form of curves. We have current versus speed in the form of torque versus speed curves. We have efficiency maps. We have and a whole lot of tabular results that you can. So if you're interested in MotorWizard, I think you should you should contact sales@emworks.com, and we will give you all kinds of information and also give you a trial of the product. Now with this, I really come to an end of this particular presentation. I would like to thank you all on behalf of EMWorks for attending this webinar. As always, you can access these webinars from our website. A link will be sent to you which carries the recording of this particular webinar, and also our past webinars are accessible through our website. We have a dedicated YouTube channel where we post a lot of videos related to our products, so you may want to visit them. And for any sales inquiry, please contact sales@emworks.com. And if you had any technical questions regarding this webinar or any technical questions in general regarding EMWorks and its products, you can write to support@emworks.com and our engineers will get back to you with the best answer possible regarding your particular application. And also finally, we stay tuned for information regarding more of our webinars, and maybe these future webinars might excite you. So with this, what I would like to do today is, with this, we would like to close this webinar session. If you have any further questions, I strongly advise you to write to us at sales@emworks.com and we will answer all of your questions. Okay. So thank you very much, and see you in a future webinar.